peak. So I'll create this test class now. I just copy this, and then I will use all insert Java class my stack test. Okay. And now let's create our basic unit test cases. So first of all, I'll create this object first, my stack. And for simplicity, I will just use string as just our element type, my stack, and let's create this new my stack. Okay. So here we are creating this my stack object here, which will be having a private field member as top, and all these three methods implemented. Now let's write our first unit test case. So let's test the basic, all the like stack implementation, whether it's push, pop, and peak, and all in one unit test. So I'll just create a test method and test my stack. And also I will prefer to give a display name of this test as test my stack implementation. Okay. Now we have got this my stack, right, which is having a type of string. So let's first start with pushing some elements in that. What we do is that we'll keep on pushing like A, B, C, D, something. Okay. So my stack dot push. Let's start with A. And control D, control D, control D. So it means that next would be B, C, D. Okay. So currently, we have pushed 4 items A, B, C, D, and it should be looking like this. So if I just draw this, so the first push would be putting A, then top would be moved to B, and similarly B, C, D. Whenever we keep on pushing A, B, C, D like this, it will be pushed like a stack, right? And the top, after this pushing the last element for D, the top would be pointing to D. So this is what after this fourth push operation would be. Now let's check our basic peak method first. The peak, I expect that it should return D, because for peak, it always just returns the value. It doesn't update the top or removes this element from the top. So I will do assert equals, and here I will put D, and this is what I expect for my stack dot peak method. Sorry, peak. Yes. Alt enter, just use this. So before we proceed, just run this test case. So we'll run this test case only asserting only one thing, that our top is written as P as D. Let me run this. So I expect that this should be running perfectly well. Okay, so it passed. Now let's this was a like very basic, you can say, smoke test, and let's implement everything else. So we have checked push and peak. And now let's check about pop. Simply use this pop method here, which means that once we call this pop, it would be again D. But only difference between peak and pop would be that now the top would be pointing from here, and it would be pointing to here, and this would be removed, right? So top would be pointing to C after we do this pop operation. So we'll assert that later on, but let's proceed on with some other cases. So now we expect that because top will be pointing to C, again, we should see that whether C is written once we have this pop here. And once we return the pop again, the top would be again moving from here to pointing to B. Okay. So let's do again, it should be B. So we are at this point at when we do peak method here. Okay. Now let's once we have at this point, now let's add another element, say E. I will just copy paste here and E here. What it means is that it would be from B here, the top will move here, and the C would be, there would be no CD anymore, it would be E here. So something like this. Let me change it. So it should be E here, this would be removed, and top should be pointing up here. This is after this statement. And then again, we can just create some more permutations like this, that we just assert equals, because our top is at E. At this point, it will be removing this element, and again it will go back from here to here, pointing to B, and this would be removed. And finally, we can again do this same statement. So this is what we all expect. We tried various combinations. Now let's run this. I'll remove this extra one. So let's run this now. I run this. I expect that as we have gone through in Excel, that what should the state. So it's all good now. So at this point, we were at that top of pointing to B. Okay, so now this is a test case that we have already done. Now we have to also write some unit test for checking the S conditions. So the S conditions are that when we get an exception here, I'm talking about this. If the stack is empty, then the pop and peak should returning this empty stack exception. So that's a very important point again to the interviewer, that we have to cover all the unit test cases, all the cases possible, all the edge cases should be covered. So that's what we have to do whenever we try to write the unit tests. We should try to cover as much coverage as possible. So let's do that for this checking this empty stack exception. So I will create another test class, test unit test now. Sorry, alt insert test method, and call it as test empty stack. Okay, and yeah, okay. At display name test when stack is empty. And we can just simply say that, because we are not, once this test is run, we are not inserting anything here. So when this test method is called, right, test empty stack is called, that time we already have this empty stack here. We just create this using the new operator, and we have got this my stack, but we haven't pushed anything as we have done here. So it means that the stack is already empty at this point. So we can directly check here at the very first statement that it should be throwing empty stack exception. Empty stack exception. Okay. Dot class. And then we will pass my stack. I can just call this using method reference. Okay. Okay, should be emp. The spelling is incorrect. Okay, empty stack exception. And control D, empty stack exception for peak as well. SR, this is empty. So let me run this now. I will run this. I expect that this should also pass because our stack is empty when we create it using the new concept, new object. Okay, so yeah, this stack is empty. So guys, let's revise again what we have done in this first problem. We create, first of all, we have the StackI interface given as a part of the problem statement, where we have to implement pop, push, and peak. So first thing that we did is that we created stack node. And the stack node is just the way that we represent the stack node here, which is having the data and the next element pointing to another stack node. So this is what we have got: two parameters, two private field members here for the stack node, and we have got getters, setters, and constructor for it. Then we implemented our my stack, which implements StackI. So what only thing that we have to check is the top parameter, which is the private field member here. For the pop, we always check that whether first we check that whether it's the top is null. If the top is null, then we throw empty stack exception. If top is not equal to null, then we get the top data, store it temporarily, and then we update the top to the next pointer, which is the item which is just below that top. And then we return the item that we have stored here. Similarly for push, because there is no capacity involved here, so we just create a node of the given argument here item, and after that because it is going to be sitting on the top of the current top, it means that this node would be having the next as top, and that's why once we updated this node as the next as top, now top is again updated back to the node. Okay, so this was push. And for peak, because we don't need to remove it the same way as we do it for push, That's why we just return the data that we have. And of course, we check that whether it's null or not. So this was the very first implementation without using any standard Java collections. In the next video, we will see that the first follow-up one, where we have to implement a stack in Java using Java collections. So see you all in the next video.